This is going to be 5.2, Chapter 5, Section 2, finding the mean, variance, standard deviation, and the expectation or the expected value for probability distributions. The two formulas I have here are the old way of calculating the mean for simple data. Now that we are dealing with probability, we're going to change those formulas up a little bit. You can review the old ones later if you'd like. We are dealing with a population now, not just samples anymore, because for a population, for a probability distribution, we're dealing with 100% of the experiment or the population or the data. So therefore, we're dealing with everything, not just a small sample. So it is a population. We'll be using mu instead of x bar. We'll be using mu. So let's get right into it. I have a formula up here. The nuts and bolts of it really boils down to this particular portion of the equation, and it says that the average, the mean, is going to be the summation of all of your x values multiplied by their individual probabilities. So I'll just point out exactly what I did. I took each credit card. Some people have 0 credit cards. That's 18%, 0.18. Some people have 1 credit card. That's around 0.44, 44%. So basically what I did was I took every one of these x values and multiplied it by their individual probabilities, and at the end I added them all together, and it gets me a mean of 1.34. That tells me that on average somebody would have 1.34 credit cards. So if I walk down the street, I would imagine most people are going to have between 1 and 2 cards in their wallets or purses. So that's how you find mean. Next, we have standard deviation and variance. And we remember from the previous chapter that standard deviation is the measure of how spread out the data will be. So the formula from before is very much the same in terms of standard deviation is this lowercase sigma, and it is equivalent to the square root of the variance. Now the variance is the standard deviation squared. But we'll get into that. The bottom line is we need the standard deviation, which is the square root of this new formula. And this is kind of nuts here. It deals with the mean squared at the end. And this portion of it right here is the summation, okay, the summation of all of your x's squared. Before it was just x's, but now we're going to square those x's and multiply them by their probabilities. So for example here, same example as last time, instead of using 0, 1, 2, 3, 4, we're going to do 0 squared times 0.18, 1 squared times the 4400ths, 2 squared times the 0.27, 3 squared times the 8 100ths, and 4 squared times the 3 100ths. Bottom line is when you add all of those numbers together, you will get the number that's going to go under this equation. Now let me show you what that looks like. If I do all of those things and I add them together, I get 2.72. That 272 is going to go under the square root symbol, and we're going to then subtract the average, the one we got from the very first page, 134, squared. If you need to use a calculator, by all means, do so. You'll end up with the 9.9244. That is actually the variance right there. 9244 is the variance. When you square root it, you'll get the standard deviation of 0.96. That is the working example of how to do this. Let's look at one more. Arrival at airport. They're showing the number of arrivals per hour, and they're saying what's the probability. So we have 5 arrivals around 14% of the time, 8 arrivals 18% of the time, and so forth. The mu, you straight up just go ahead and take 5 times 0.14, 6 times 0.21, and so on. Adding them all together gets 7.22. So that's going to be your mean. On average, per hour, you have 7.22 flights or arrivals for each hour, okay, during the day. How spread out are they? What is my standard deviation? Well, I'm going to follow my formula, and that 722 is going to go right here underneath mu squared. So we're going to go to the next page and say, listen, to find the first number that goes under, we need to take the squares of all my x's. So I come up and I say 5 squared is 25, 6 squared is 36, 7 squared is 49, and so forth, each one getting squared, and then multiplied by the probabilities. Okay? Multiplied by those probabilities. When you do that and you add them all together, you will get 54.3. Okay? And if you want to see what those numbers look like, I'll show you. 25 times 4.14, 3.5. 36 times 0.21, 756, and so on. And when you add them all together, you get 54.3. I did that with just a little Excel program. Now, plug that 54.3 back in, minus the 722, which is my average, my mean, squared, and then figure that out with the calculator. You get 2.17 as my variance. Square root gives me my standard deviation, and lest we forget the 722 was always my mean. And you're done. It'll take a little practice to get good at it. Last but not least, we have what's known as expected value. When you have carnival games, they charge you for your chance to win prizes or money. The expected value of what is a fair game will be the probability of you winning multiplied by what you will win. So in this case, if I get paid $5 for rolling doubles, I will win $5. The probability of rolling doubles would be 6 doubles out of 36, which reduces to 1/6, and $5 times 1/6 is 83 cents. So if they charge me more than 83 cents, it's not a fair game. And most carnival games will charge me $1, even $2, and that means they, on average, will absolutely make money in the long haul. Sure, you may roll in there and roll a couple doubles and they pay you out, but over the course of their entire day or the hour, they will definitely win money. So, that's been 5-2. Have a great day. Thanks.